Or good afternoon, everyone. Thanks for joining today's event. We will wait a couple of seconds, 1 minute max, so that everyone that register can join in time. And then we will start our webinar with the topic of fluid and powder simulation made easy. Morning, I see you're joining in great number. So let's wait just a few seconds. Hello, hello. And we promote this methodology all around Europe. And today we will talk about fluid and powder simulation made easy. So let's quickly discuss the agenda of today. You can see that we will introduce Granuleworks, this solver for powders. That is a mesh-free solver for powders. We will discuss the physical and numerical models integrated in the solver, and then see the couplings that we have for fluid, air, and multi-body, so multi-physics capability of the software. And at the end, I will also discuss industrial applications and give you an overview of where the methodology is applied right now. So Granuleworks is an advanced simulation software for granular materials. And basically, it's based on Discrete Element Method. So it's a way to treat powders as solid interacting with each other and mixing. And the applications are various in machinery or civil engineering, as well as food and consumer goods, as well as chemical engineering, so mixing, compacting, dosing, and mixing of food or pharma, let's say, components, chemicals, and so on. But also, as mentioned, civil engineering is a field of application. We can analyze cliff collapses, debris flow, and also concrete analysis. So we will see in a few slides all of these applications visually as well. Just one slide on the solver. So as mentioned, is a mesh-free approach. So that means that rotation or shaking or movement of any object interacting with the powder can be easily applied, and it's not troublesome whatsoever for the user. And as you can see, we model the powders as particles, and we analyze their interaction with Newton's equations of motions. So rototranslation of the powders as well as their interaction can be evaluated with the software. So the models that are integrated in Granuleworks are different. We have a liquid bridge model because if the powder is wet, we have some surface tension effect that keeps the powder compact. Van der Waals forces are also integrated in the solver. Again, when we deal with very small particles in the range of 100 microns, we have electrostatic interaction and charge between particles, and because of that, the behavior of the particles is slightly different than if it wasn't. Then we have rolling resistance model, so the, let's say, ability to have the interaction between particles and the losses between the walls and so on, and also the thermal solver. So we have the capability also to integrate temperature variation in the powder if we have like different temperature on the walls, for instance. We can also define multi-dimensionality on the particles. We have here an example of a user-defined granulometry, and this is a filter, multi-layer filter, where particles that are smaller can flow through during the shaking, while the biggest particle are stuck on top. So we have different possibilities to define particle distribution. Could be user-defined, but also log normal or Rosen-Ramler. Talking about the shapes of the particles, we can also have not only spherical, but rectangular, capsular, and cylindrical shapes, but actually also custom define files defining the dimension and the structure of these particles. So there is a very wide range of application here that are now possible, especially with the new release that integrated this capabilities. So as you can see here, of course, the particle dimensionality effect are important for this kind of like shaking behavior in horizontal shaking, because the particles are, let's say, elongated in this direction. They don't flow through that easily, while with vertical shaking, we can see that there is a greater flow to the bottom side. And here is another example for screw separation and movements. So we have a vibrational spiral feeder here on the left that selects and orients the screws in order to stack them correctly. And you can see here that there is an interaction with the upper side of the screw, and then they are dispersed in this container. And on the right as well, there is a selector and a feeder mechanism with slightly different kinematics. So as you can see, we can easily apply vibrations or let's say complex kinematics without any issue. It's interesting to see also this filter application when also dealing with custom shape particles. So we have cylindrical, rectangular, and multi-diameter. And you can see the clogging that can occur, or let's say, again, the different outputs in terms of flow depending on the shapes. We have here a glimpse of one of the coupling that is possible between Granuleworks and other solvers. In this case, it's Particleworks, the other solver, because the fluid phase is modeled with that solver. We will discuss it in a few slides. In terms of like other physics that can be captured, there is also this important parameter, the angle of repose in powders, so that this can be tuned depending on the let's say material parameters. Of course, there is a wide range of physical settings that can impact the behavior of the powder, and those can be tuned inside the software. So to achieve, for instance, different angles here, as you can see, depending on the friction coefficients between the particles. And it's interesting to see the angle of repose also influenced by the, let's say, shape of the particles and the final shape of this, let's say, accumulation of powder or solid elements. There is also this method that allows for faster simulation. It's called SDEM, so Scalable Discrete Element Method. And basically, it can represent some powder distribution with a scaled powder size. And this results in, let's say, smaller number of particles to be modeled and time step that is, let's say, more, it's faster. So because of that, we can achieve similar results, but with significantly faster simulation times. You see here we can sacrifice a bit of resolution, but achieve, let's say, similar outputs and the results. So there is this nice feature that, again, gives us flexibility in the simulation workflow. Let's talk now about multiphysics and the couplings that are integrated with Granuleworks. As mentioned, Particleworks, a meshless solver for fluids, is actually coupled and is actually integrated in the same interface as Granuleworks. So you open up a software and you can either go for granular, fluid, or fluid granular simulations. So you can see here an example where we have a fluid in green for a separator and solid waste in let's say brown or like dark green. So you see the effect of centrifugal forces and the influence between the two phases, and then the discharge of the solid waste. Sorry. On the right, we have a mixer with powders on top and a very viscous fluid on the bottom. So the fluid is modeled with Particleworks, and the powder distribution is seen as Granuleworks. And here is another very interesting example. We have on top here a viscous additive to a granular, let's say, matrix. So let's skip it. So you see here some agitators, and we have two granular species at the beginning of the simulation, feeded, and then the viscous additive. And we can see the distribution of the viscous additive in the granular phase, as well as the granular distribution. You see here the viscous phase accumulating on the left, and then we can also evaluate the mixing index. This is a parameter. When it tends to 1, it means that basically there is a full mixing between the two phases, and you can see and you can track it over time. Talking about some industrial examples and real-life applications, we have this paper publicly available in collaboration with Gamma Meccanica and Lorenzo Iorio. They presented to our conference 2 years ago about plastic recycling machines. So the idea, and actually if you want to read further, it's also a paper on our newsletter. So you can scan the code and grab your copy. So the idea is that you have a mixed inflow of pellet, granular material, plastic pellet, and water on the right. And the objective is to have the two phases separated and actually have the plastic separated on top while the water can discharge at the bottom. And of course, there is a separator, a rotor that can and was also improved in terms of like separation efficiency. So you see the level of water, what is the max level of water. This could be, and usually is needed to be lower so that the losses because of the operation are lower. But then at the same time, you want better and faster separation. So those were the objectives. And actually there was also a visual, let's say, testing example in-house at Gamma Meccanica. And they could already see very interesting correlation between the prediction of simulation and the real life testing. You see here the flow distribution of the granulate plotted against the rotor, and you see the flow that is also represented there. So as mentioned, the objective was to optimize and make the granulate reach the upper part faster. And you can see how different rotors geometry that were tested very easily because of the meshless approach. So you can see that given a different geometry here, we have faster flow at the top. And at the same time, we could monitor the powder, the rotor power consumption, because of course the geometry will impact also that. And at the end, they could optimize both of these output and choose the best rotor design among three. Another example of this coupling between fluid and powders is a decanter centrifuge. So in this case, we have, again, a mixed phase coming in the center, and because of the, let's say, rotational forces, we have water going out in the recovery area, while the sludge in this case, so the solid sludge, can be separated in the front. So just to give you an idea of other type of systems that are investigated here, you see the results of the rotations and the fluid phase, as well as the distribution of the powders. And here is the inlet, so where you have, let's say, the mixed phase between granular solids and fluid. Talking about other integration, we have the possibility to integrate also air solver, an air solver, again, with Particleworks. In this example, you see, let's say, some dust or like sand on the ground, and the air field that basically generates in the rotation of the wheel, and there is a complete coupling between the two, and everything is meshless. So the FVM solver here is based on a Cartesian grid. So at the beginning of the simulation, all the domain is discretized automatically by this Cartesian grid, and there is a one-way or two-way coupling between the powder and the air phase. And here are some examples of this coupling. So a vacuum cleaner, so we can apply, let's say, an aspiration pressure at the top here, and we see the granulometry on the ground, and we see that with higher pressure, operating pressures, we have better respiration. And on the right, we have a transport of powder with an air inlet here, okay? So fully coupled air powder simulation without any issue. And of course, this can be applied for fluidized bed, for instance. So the idea is that we have a powder bed and an inlet, air inlet at the bottom that moves the powders around. And you can see here one output could be to monitor the flow of particles at different locations of the fluidized bed. Again, all of this is in one interface, all meshless, very easy to set up for the user. And the last coupling I want to discuss is with the Recordine. This is a multi-body simulation software. In this case, it's a separate, let's say, tool, but as a tool that is fully integrated with Particleworks and Granuleworks. And basically, Recordine can handle contacts between solids and define forces and solve for the kinematic laws applied to a certain solid body. And the Recordine also offers a multi-body, a flexible body solver. So you can see here on the left, there is a coupling between the solid flexible, full flexible body and the granular material. So very complex meshless simulations available for more complicated mixing system. And this can also be applied in machinery or like civil engineering type of application as mentioned. We have actually also all the movements here analyzed by Recordine and powders interacting with the solid and also resulting in von Mises stresses. So you can see that the solid, the motion is influenced by the powders in this coupling. You see clearly. And let's now have a quick overview of the application visually. As mentioned, we have excavation, so machinery operation, mixers for cement, drilling, but also excavators. Those can be analyzed. I will come back to the cement example in a few slides because it's very interesting coupling. Then we have mixers with different type of shapes or like kinematics, also confirmed experimentally quite nicely here. Again, we don't have issue in the complexity of the rotation or the geometry because everything is meshless. So the user doesn't have to simplify the geometry or prepare the CAD for the simulation. Here are a couple of more examples. So we have shakers, feeders with different variation of the geometry and analysis of the influence of this, let's say, system to improve the mixing or like to keep the mixing constant depending on the objectives. Multi powder feeder and also again a shaker. Chemical coating and dispersion of elements can also be analyzed. Here is the results at different time frames compared to, let's say, the physical testing that was available in this case. You can see the dispersion of particles at different rotational times. And you can see that slowly the coating gets through the entire barrel. And compression is also something that we can analyze. So powders will be compressed and we will have elastoplastic models inside Granuleworks. So shapes can be created by, again, compressing the particles and tuning the interaction parameter of the particles. And this results in an application like drug tableting. So here we have a full system that presses down the original particles that are in this mold. They get shaped and then they can be transported by the system. So quite easily achieved with all the kinematics without problem. And as mentioned, in terms of material, we have the possibility to analyze concrete. Concrete usually is a mixture between let's say a more fluid phase, that is a slurry, a viscous slurry, and then some powder aggregates, some fillers or rocks, bigger rocks. And we can see that we have different type of flow depending on the amount of filler we put in the cement phase. And you can also monitor the solid flow rate a different operating point. In this case, it's a cement mixer, but you can also have like this kind of flow that could be more for civil engineering application. And talking about other models or like materials, we have the possibility to model snow and the adhesion between snow particles. You can see that there is accumulation there, and then after a certain weight is reached, there is gravity prevailing on the adhesion forces between the particles. And on the right, we see some thread patterning of a snow simulation as well. So just to summarize a bit, and then I would like to answer your question or open up a Q&A session so that I can better address your points. To summarize, Granuleworks is a discrete element solver. So it solves for Newton laws of powder interaction. It integrates rolling resistance, angle of repose, liquid bridge, and van der Waals models, as well as custom shaped and user-defined granulometry. We have several possibilities of achieving multiphysics with fluids, air, or rigid bodies, also flexible bodies with Recurdyne. And then the applications are different in food and beverage, pharma, machinery, civil engineering, and also material processing. So you have here some of the examples that we covered. This is another example of coupled mixing and compression of some granular material. And yeah, before opening up the Q&A session, I just want to let you know that you can test the software yourself with our support. We offer a free trial of the software. You just have to write me, an email mentioning your interest and maybe the application you have in mind, and we can activate this license for you and give you support to build your custom model. Okay, so I covered the material I wanted to cover for now, but I'm pretty sure there are a lot of questions about the solver or like maybe the hardware requirements and so on. So please just let me know about any concern you might have in the Q&A session there. Or in the chat. I hope everything was clear. Feel free to comment or ask any question. So while we wait maybe for some curiosity, I didn't mention it, but the meshless approach and the solver actually is optimized also for graphic cards solving. So you don't need a big cluster to run this kind of simulation. It's usually achieved on a workstation very easily. You can run on CPUs, but yeah, also graphic cards are very efficient. So Matteo asked the first question, is it possible to simulate wettability surface simulations? Yes, the wettability is one of the parameter and something that can be monitored inside the software. The wettability between particles or like also on the solid walls, actually, usually. if that is the objective. So you can check what, let's say, what walls are touched or wetted or actually also eroded the most. So erosion models are also possible. Thierry asked if this can be run on browseware. Let's say yes or no. I mean, yes, meaning that we have a cloud option that, yeah, basically is a browseware only option. So you don't need to install or get a license on your local machine. You can connect to this cluster with the GPUs available. And if you grab some credits, some coins, you can then run simulation. So yeah, Thierry, I would say that is possible. And it's also the best way to start using the software if you don't have full scale capabilities on the IT or hardware side. Thank you for the questions. Any other curiosity that you might have? Very fine powder mixing, Henning asked. Yes, I mean, we can define a custom granulometry up to microns, so few microns in dimensions. So we don't have a, let's say, strong limit in terms of like what is the dimension of the particle we can handle. So ideally, if your hardware enables it, you can go to few microns. It all depends on the total volume you have to discretize, of course. If you have huge volumes and you have small particles, then simulation time can be a little bit long. So we are available on the website Particleworks Europe. So if you want to also read through the products here, you see Granuleworks and you can see all the topics we covered and some more videos perhaps. And you have also all the contacts information. And Particleworks Europe is also on LinkedIn. So you can follow us on LinkedIn as well. And you can keep track of every new events. But perhaps the best way to get in touch is, and maybe to understand further, is to try the software yourself. It's very easy. It doesn't require to be a numerical wizard, let's say, a computational hydrogen engineer expert. So you can try, and usually in a few weeks of usage of the software, 1 week or 2, our customers are able to run effectively some simulation in this topic. So if you're curious to hear more, reach out to us. Any more question? Do you have any idea of application in your sector? Okay. So if everything is clear, I think we can call it for today. And I want to really thank you for your participation and interest in the software and for your time today. Again, I hope we can keep in touch and get in touch to follow up with you all and to help you understand better how the software could improve your R&D workflow in different applications. So again, thanks you all for joining, and be sure to reach out to us if you're interested to hear more. Have a great day.